This will be a review lesson for our Chapter 11 and 13 test. This is from the back of the review, an AP exam question. I'm going to go through it pretty quickly. A lot of these concepts we've talked about in the chapter. So here's what we've got. The formula and molecular weight of an unknown hydrocarbon, remember this means a compound made of hydrogen and carbon, are to be determined by elemental analysis and the freezing point depression method. This is what we talked about in Chapter 13. And here is what we begin with. The hydrocarbon is found to contain 93.46% carbon and 6.52% hydrogen. Calculate the empirical formula of the unknown hydrocarbon. Now this goes back into calculating empirical formulas. If you remember, we had a poem, percent to mass, mass to mole, divided by small, multiplied to whole. Let's go ahead and apply that. The first step is to get the percent to mass, so really we have 93.46 grams of carbon and 6.54 grams of hydrogen. The next step was to convert it into moles, so we'll divide by the molar mass. A mole of hydrogen is 101 grams. A mole of carbon is 1201 grams. So if you do 93.46 divided by 1201, we get roughly 7.78 moles. Down here, we do 6.54 over 101, we get 6.475 moles. The next step, recall, was to divide by small. Dividing by small, the small one is 6.475. We divide by 6.475 for each of them. The bottom, we get 1 mole. The top, if you divide, you get 1.2 moles. The last step was multiply to whole. Why do we multiply 0.2 by to get a whole number? By 5, because 0.2 is a fifth. So multiply both these by 5. You get yourself 6 carbon atoms, and you get yourself 5 hydrogen atoms. The empirical formula then for this compound is C6H5. So this is a quick exercise in what we've done before in the previous chapter. It's a good idea to review this for the final. Next, we're going to get into the Chapter 13 material. A solution is prepared by dissolving 2.53 grams of p-dichlorobenzene. They give you the molecular formula, or the molecular mass, in 25.86 grams of naphthalene. They also give you the molecular mass here. Now naphthalene will be our solvent. That's what we are dissolving in. And p-dichlorobenzene will be our solute. So what they want us to find is the molality of the solution. Now molality, if you recall, was the cursive M. It's moles over kilograms of solvent. So the moles can be accomplished by dividing grams by the molar mass, just grams to moles. So we have 2.53 over 147. I'm doing this again quickly, but this is what you would do if you would set it up from grams to moles. Exactly the same thing you would actually divide by the molar mass. On the bottom goes kilograms of solvent for molality. So our solvent is 25.86 grams, except we have to put it in kilograms. Let's divide by 1,000. Move the decimal place thrice to the left, and you get yourself this arrangement. So if you do this properly, if you divide these two numbers, 2.53 over 147 over 0.02586, we should get ourselves 0.6655 molal solution, or you can say moles per kilogram. Okay, so we got that, not too bad. The next step, step 3, says the freezing point of pure naphthalene is determined to be 80.2 degrees Celsius. The solution prepared in B is found to have an initial freezing point of 75.7 degrees Celsius. Calculate the molal freezing point depression constant for naphthalene. We're going to use the equation that has the change in the temperature of the freezing point equals the constant for the freezing point times molality. This is the freezing point depression equation that we've talked about in this chapter. So what they tell us is that the change in the freezing point after you add the substance goes from 80 to 75.7. So if the change, remember, is final minus initial. So if we subtract these two, we should get ourselves, it looks like 4.5. That's about right. 4.5 degrees Celsius. So we have 4.5 degrees Celsius equaling Kf times molality. Kf is what we're going to solve for. Actually, molality is going to be the same thing we just used up here. Our molality is this number, 0.6655 for our molality. Kf then will simply divide this over down here, and Kf will be 4.5 degrees C over 0.6655 for a total of, go ahead and divide those two numbers. Looks like 6.76, in this case degrees Celsius per molal. This is our Kf. This is what we would use for further problems involving naphthalene. Now what we're doing in the end is you'll see that we're going to try to solve the empirical formula. We have the empirical formula, we want the molecular formula, and this will help us determine it. So let me scroll down a little bit. Remember that number 6.76. And let's try to do the last few portions here. Down we go, down we go. Just two more. Not bad. Okay, now we've got a solution. We're putting by the way, this is 6.76 we said, degrees Celsius per molal for our Kf. A solution of 2.42 grams of unknown hydrocarbon is dissolved in 26.7 grams of naphthalene and found to freeze at 76.2. Calculate the molecular weight of the unknown hydrocarbon on the basis of the freezing point depression above. So this is actually going to be the molecular weight of the hydrocarbon we began with at the very beginning of the chapter, or the problem. So in this case what we do is we're going to apply that same equation. The change in the freezing point equals the Kf times your molality. In this case, however, the change in freezing point is a little different. So we went from, initially we started at, if you remember, 80.2, which means the difference here would be exactly 4. Correct? Exactly 4.0 degrees Celsius. The Kf we solved for, here it is, and the molality is what we're going to use to pull out the moles. What we're looking here at is getting the moles. Now we have grams. If we have moles, then we can find molar mass, because remember, molar mass is grams per mole. So what we'll do here, the Tf would be 4.0. Let's go ahead and set this up. We have 4.0 equals, our Kf is 6.76 degrees Celsius per molality, and multiplied by our molality. So to solve for molality, we'll divide this out this way, and we should get ourselves 4.0 over 6.76. That will get us our moles. So 4 over 676. We should get 0.5917. Now this is molality. Remember, molality is moles over kilograms. Here it says that we're dissolving it in this many grams. So our kilograms is actually 0.0267. Now we can solve for moles. If we multiply this number out there, our moles should equal 0.01558, we'll say. Here's how many moles we've got. Now we've done this in a problem that involves the WebAssign. So essentially you're using the freezing point depression to pull out moles out of molality. That is the whole point. Now because we've dissolved, we began with 2.42 grams, we can now find the molar mass. 2.42 over the moles, 0.0158, getting us. So we got 2.42 over 0.0158, 153 grams per mole. 153 grams per mole. So here is our molar mass. We are almost there. The last thing they want us to know is the molecular formula. Now we'll compare this against the empirical formula, which was, remember, C6H5. If you add these up, what you'll see is that this is roughly 77 grams per mole. Remember, in order to get the molecular formula from the empirical formula, you would compare the masses. You would compare the mass of the molecular formula, which is this, against the mass of the empirical formula. I'm sorry, the mass of the empirical formula against the mass of the molecular formula. Do you see that it's roughly 2 times bigger? 77 times 2 is 154. So we'll actually multiply this by 2 to get a total final formula of C12H10. And here it is. I know this was rough, this was quick, this was deep. Pause it, rewind, rewatch, invite some friends, and get ready for the test that will cover this concept. A question like this would be on the extra credit, most likely. So we'll see you in class. This completes for us the lesson.